hydrogen is fused into helium at a temperature of 15 million degrees Celsius. As a result, enormous amounts of energy flood out. The sun's surface is a turbulent sea of hot ionized gases. The tops of huge convection cells mix, boiling on an enormous stove. Here and there we find darker regions called sunspots. From such places, powerful flares, coronal mass ejections, blast outward across the solar system. Our sun can be a violent place indeed.
কত সুন্দর যে এরকম করে হলো ওঠে মেটিওরস না এটা হয়
150 million kilometers away. Our planet is shielded from such solar tantrums by an invisible magnetic field, subduing them in hauntingly beautiful displays of the northern and southern lights.
টিপিনি সুন্দর প্রথম থেকে ভিডিওটা করছিলাম টিপতে ভুলে গেছি
As the Russian space pioneer Tsiolkovsky once said, the Earth is the cradle of civilization, but one does not stay in the cradle.
ঠিক আছে খেয়ে দেখবো আমরা তো মজা করি
We now live in the greatest age of discovery in the history of the human race. 500 years ago, great explorers sailed out across then vast oceans to bring us tales of new continents. Today, even tinier craft fly the vast ocean of space. Send us amazing an entire world to explore. Closest to these is our own moon. At a distance of 384,000 kilometers, the moon is our nearest neighbor in space. Barely 1/4 the size of Earth, is a dry, airless, lifeless world. Above, a place called Earth hangs in a black sky, embedded with dazzling stars, and always utter silence. Yet the moon is not without its own, albeit stark, beauty. Thousands upon thousands of craters pepper the landscape. Long ranges of mountains thrust upward, some with peaks that soar to over 5,000 meters.
ওই প্রজেক্টরের একটা প্রবলেম আছে দেখো এই যে লাইন হয়ে যায় ওই যে লাইন এদিকটা বাঁ দিকটা দেখা
welled up from the moon's interior, flooded the lunar lowland, and ultimately froze in place. In the late 1960s and early 1970s, American astronauts journeyed here. Their scientific instruments, lunar rovers, footprint, bear testimony to these visits and will last for millennia to come. Someday, humans will return, perhaps to set up permanent scientific bases, perhaps to pave the way for the first cities to be built on another world. Barely larger than our moon, tiny Mercury hugs the solar glade. Its surface also displays signs of a tumultuous past. Across its surface lie great plains strewn with craters. Cliffs that break the landscape for hundreds of kilometers and a giant impact basin called the Mare Caloris, or Sea, where an asteroid crashed billions of years ago. Heat is the operative word on Mercury, for, during the day, surface temperatures soar to levels hot enough to melt tin and lead. Yet, in the long, airless night, they plunge to over 170 degrees below zero.
Plane করে যাচ্ছে
Beyond Mercury shines dazzling Venus, enshrouded in silvery clouds. In Greek and Roman mythology, this was the goddess of love. But, while beautiful, the planet's enveloping clouds are actually made of choking carbon dioxide, laced with droplets of sulfuric acid. The result is a runaway greenhouse effect that traps the sun's heat so well, day and night, equator to poles, temperatures at the surface bake at over 460 degrees. Soviet Venera spacecraft sent our first true glimpses of Venus's surface from their landing site, before quickly succumbing to the intense heat and pressure. From a safer distance, the U.S. spacecraft Magellan used powerful radar to pierce Venus's veil of clouds and map the mysterious planet below. It revealed long, rolling plains, strange pancake-shaped structures, huge volcanic peaks that once spewed rivers of lava and flood vast canyons below. Could enormous volcanoes still belt fire and sulfurous ash today? Recent evidence from the European spacecraft, Venus Express, suggests that this may well be true. Venus may be our closest planetary neighbor, but it provides dramatic testimony to how different neighbors can be. For while Venus was named for the goddess of beauty and love, in reality it comes far closer to the biblical description of hell. Beyond Earth lies Mars, accompanied by its two tiny potato-shaped moons, Deimos and Phobos. Mars is a world of dune-covered deserts, dark markings, and gleaming polar caps. Dust devils swirl across its rusty plain. Great dust storms periodically rage, obliterating all that lie in their path. But the atmosphere of the red planet is usually clear, and reveals that Mars, while barely half the size of Earth, nonetheless boasts an amazing array of natural wonders. From high above, we peer down on a quartet of ancient, extinct volcanoes, including Olympus Mons, the largest such feature in the solar system. It towers 20 kilometers above the surrounding plains, and, if brought to Earth, would cover all of France. Equally mind-boggling is the Valles Marineris, or Mariner Valley. Up to 200 kilometers wide and 6 kilometers deep, the Valles Marineris is a vast canyon system that would crack Europe from Portugal to Moscow, or span the United States from New York to California. Today, Mars is colder on average than Antarctica and drier than the Sahara. Yet, the recent discovery of dark streaks on mountain, crater, and canyon slopes points to seasonal flows of salt water on the surface of Mars. Furthermore, 3 billion years ago, when its giant volcanoes were active, Mars likely had a thicker, warmer atmosphere that allowed ice, now locked beneath its surface, to flow as rivers and pools and lakes and seas. At that time, could life have arisen? Today, tracks in the soil don't show evidence of dune buggies driven by teenaged Martians, but rather robot spacecraft from Earth. They prowl the Martian landscape looking for conditions that might have been conducive to life in Mars's ancient past. Their human creators may someday follow. But, in an ironic twist, some wonder if an impact from space long ago could have blasted rocks from Mars that contained life and rocketed them to Earth. In short, could we all actually be Martians? It is a fun question to ponder. Beyond Mars lies the asteroid belt, fragments of debris left over from the formation of the solar system, fragments that gravity could never mold into a single planet, fragments in endless tumblings about the sun. Emerging from this cosmic boulder field, we enter the gateway to the outer planets. Jupiter, a world so large that 1,300 planets the size of Earth could fit inside it. Its striped face marks the tops of enormous cloud systems. Here, ammonia snows swirl in blizzards of gigantic proportions, while deeper down, ammonia rains are unleashed in torrents. Lightning bolts flash with energies that would vaporize earthly cities. Along the boundaries between the white and multicolored clouds, jet streams streak at speeds of up to 350 kilometers per hour. Giant Jupiter is the largest planet in the solar system, yet it also has the shortest day, less than 10 Earth hours long. This dizzying spin, coupled with enormous heat welling up from deep inside, craft enormous storms. Among these is the Great Red Spot, a vast cloud complex more than twice Earth that has been raging for at least 400 years. While Earth has but one moon, Jupiter plays host to over 60. Orbiting close by is Io, a bizarre clown face of a world. The reason for its appearance lies in Io's tortured existence. It is the victim of a tug-of-war between Jupiter and neighboring moons. They push and pull, endlessly contorting Io's surface and heating what lies beneath. The molten interior erupts through cracks in the surface and explodes into the near vacuum of space as the largest volcanoes in the solar system. Multicolored sulfur snow shoots 300 kilometers into the sky and then drifts downward to repaint the landscape in surreal splatters of yellow, red, black, and white. Io is a world literally turning itself inside out. Next outward is Jupiter's moon, Europa. Its surface a mosaic of cracked ice. Below lies a worldwide ocean, possibly rich with organic molecules.
Nice.
Future spacecraft may land here, drill down through the crust, and explore Europa's alien sea in search of possible life. Lord of the Rings, Saturn, jewel of the solar system. Like Jupiter, Saturn is a gas giant planet with an atmosphere thousands of kilometers deep. Below the clouds, there is no solid surface, but instead an unearthly ocean of liquid metallic hydrogen. Saturn's clouds are also rife with storms. In places, it rains ammonia in hurricanes the size of Asia. Elsewhere, every 30 years, an ammonia blizzard erupts and spreads in weeks to completely encircle the planet. But what drives our fascination the most is Saturn's magnificent adornment of rings. They span nearly 300,000 kilometers, yet in places are little more than 30 meters thick. And what appears like a translucent solid to the eye is actually made of billions of pieces of ice. They range in size from boulders as large as a house to tiny grains as fine as tins, all whirling around Saturn at blurring speeds of up to 85,000 kilometers per hour. Saturn's gravity also commands a host of moons and moonlets. Perhaps the most intriguing of these is Titan, a smog-shrouded world more like a planet than a moon, with 2.5 times as much atmosphere as Earth. Beneath are found giant dunes that run for hundreds of kilometers, mountains made of solid ice, and lakes filled with liquid ethane and methane. Mountains, dunes, rivers, and lakes. Familiar features. But at 180 degrees below zero, Titan is a world far different from Earth. Uranus, another gas giant planet, lies nearly 3 billion kilometers from the Sun. It also has a set of rings, but these are narrow and dark compared to the ones that adorn Saturn. The likely victim of a colossal collision in the distant past, Uranus travels on its side as it slowly lumbers around the distant Sun. Among Uranus's family of 27 moons is Miranda, itself a world nearly destroyed by a great collision in the ancient past. Today, Miranda is nothing short of a wonderland of varied geological terrain, like a great three-dimensional jigsaw puzzle that got blasted apart and fell back together in chaotic fashion. Among its impressive features is what may well be considered one of the true wonders of the solar system. Cliffs of sheer ice up to 16 kilometers high. Beyond, bathed in perpetual twilight, we find Neptune, host to swirling storms, methane blizzards that would stretch from New York to Paris, and the fastest winds in the solar system. Neptune's largest moon, Triton, is also worthy of note. The spiraling weather systems, vast fields of methane geysers, geysers that blast their spray nearly 8 kilometers into the sky. At the icy fringes of the Sun's domain, we enter the realm of the dwarf planets, including Pluto. Visited for the first time in 2015 by NASA's New Horizons probe, reddish Pluto surprised with a geologically young surface of vast heart-shaped land, glaciers of frozen nitrogen, and ice mountains up to 3.5 kilometers high. Charon, the largest of Pluto's 5 moons, also did not disappoint, with a dark polar cap and canyons up to 1,000 kilometers long and 6 to 9 kilometers deep. And shrouding all is a vast spherical halo known as the Oort cloud. Here dwell millions upon millions of chunks of dirty ice, the makings of comets which, if drawn inward and heated by the sun, vaporize to grow magnificent tails. Billions of years ago, countless comets bombarded the Earth and may have brought water and organic molecules that ultimately led to life. Could there be other solar systems beyond our own? For a long time, all we could do was wonder. Now, in less than a quarter of a century, we have discovered over 2,000 planets in orbit around other stars. For the present, such visions must remain the work of talented space artists, worlds even more exotic than those in our own planetary system. But, in time perhaps, we may discover the holy grail of such searchings. Planets not too unlike the Earth, in orbit around a star like our Sun. Planet inhabited by beings who, like us, have built great instruments, radio telescopes that can search out greetings sent from the stars. Beings who, like us, look up at a starry sky and wonder if they are alone.
Fleet of international spacecraft, headlined by a core U.S.-Japanese satellite, will produce the most precise global rain and snow data ever. Called Global Precipitation Measurement, or GPM, the mission promises to transform how we even think about rainfall and freshwater management. And measuring total rain is just the beginning. Insight comes from careful distillation of data, helping experts turn streams of observations into rivers of useful science. Although we've studied the water cycle before, surface radar and rain gauges don't provide enough measurements. Even with all of the red dots on this map, vast stretches of land are empty, and the oceans, the largest portion of Earth's surface, have no rain gauges at all. Satellites flying above see everything. GPM provides perspective, detail, and precision. Perhaps you've never considered this. Saltwater oceans evaporate fresh water into the atmosphere. As winds fetch their way across endless blue, air picks up moisture from evaporation, adding water to the atmospheric layer closest to Earth's surface. There's only one way moisture can go higher. Atmospheric plumes called convective towers shoot moisture high above the Earth. This moisture helps regulate climate. Some water will inevitably drop as rain over land, but most will fall back into the sea. Rain is often a harbinger of severe weather. With the right conditions, mighty tropical storms can spin up, some set on collision courses with land. These storms, hurricanes and typhoons, some of the most powerful things on Earth, demand accurate forecasts and emergency responses. How does GPM work? Satellites are like surgical suites. They have specialized instruments to do specific, highly precise tasks. GPM sensors can see inside weather system structures, through clouds in other words, like CAT scans looking inside human bodies. Once processed, the data will reveal 3D images of internal cloud structure. Along with corresponding rainfall rates, scientists will gain new insights into how water falls around the planet. Through its unprecedented global data collection, GPM will improve water management at local scales. And let's face it, you live at the local scale. Looking down from above the thickened sky, everything is clearer. Evaporated water condensing in the atmosphere falls out, stirring dull roots with spring rain, ensuring life for billions. Too much rain, floods. Not enough rain, drought. Water, humanity's timeless connection to the natural world. From food production to urban sustainability to one of the most important international strategic assets, fresh water is always the ultimate natural resource. Global freshwater management promises to be one of the most complex political and engineering challenges of the 21st century. Endlessly in transition, water shapes the physical and living earth, even as humanity tries to harness it. With GPM, the poetry of rainfall, and the rigors of accurate data flow into meaningful science.